Hello, in this video, we're going to be talking about the gray and white matter of the brain. So let's not waste any of your time. Let's get right to it. Now, when we're talking gray and white matter of the brain, the first thing that we want to reference before we talking about the properties or the structure is the fact that the colors are switched or flipped in the brain as compared to what they were in the spinal cord. In the spinal cord, the gray matter, the butterfly shape, was inside of the white. In this case, the white matter is, as you can see, inside the gray matter, and the white matter makes up a large portion of that. But that kind of that more pale white, off-white, cream color white, and the darker pink or peach, whichever you want to call it, is on the outside. So the gray matter makes up the edge, the edges of the brain on the outside, the exterior, and then the white matter makes up the interior, where the exact opposite was true in the spinal cord. Now the white matter gets that color from all the myelin that it has. It's covered, almost completely covered in myelin as far as the axons and stuff, which as we've talked about in the past, speeds up processes of getting signals and all that stuff. But then the gray matter on the surface covers that, and that's going to house all the various areas of functions that we're going to talk about. Now, when it comes to the white matter, as we mentioned, it gets that color from all the myelin that it is, and it's kind of the deep areas. I mean, if you think of your muscle, the thigh muscle, maybe it's the largest one, and we can think about that. We're all familiar with that one. But the idea of the outer edge of the thigh muscle would be the gray matter, and then all that stuff on the inside would be the white matter. So much larger, much deeper, and it's full of obviously axons and neurons and stuff. But the thing we're going to really think about is the tracks, and we're going to talk some more about those in a little bit. That's getting information from not only from side to side, but around the areas of the cortex and the cerebrum, to the areas that handle that particular function. We'll talk about all of that. All right, so again, white matter, myelinated nerve fibers. Okay, they're signaling the signals moving all around the cerebrum and everywhere else that it needs to go. It's handling those, so whether it's coming up from the sensory up through the spinal cord, through the brainstem, and into the white matter and around to whatever gray area it needs to. Okay, that process is dealt with, decided, handled, and then back into the white and down into the particular tract that it goes through, and then out to wherever it needs to go to. So very sophisticated process, but again, once we open the brain up, it is surprising of how little there is to see in there. Now, when we're talking, we mentioned tracks, and on the next screen we're going to see an image of these, but there wasn't room for both, so I'm going to tell you about them now, and then I'm going to show them to you on the next, as I said, on the next screen. So the white matter has three particular tracks: the projection tracks, the commissural tracks, and the association tracks, as you can see there. The projection tracks are the longest. Well, I shouldn't say that, because the association goes from the brain out to all the rest of the body, so it may actually be longer. But the the projection tracks covers the exterior portion of the brain, and almost in a wavy type fashion, almost symmetrical, artistic kind of weaving through the exterior. It isn't just like it lays on the surface. It's a wave-like is the word I was trying to think of, but just kind of up and down, making these pathways. But that's to get the information from to these different areas of the brain that handle that particular function. So whether I'm trying to write, whether I'm trying to speak, whether I'm trying to draw, whether I'm trying to walk, any information that's going to, is handled by that a particular area of the cerebrum or the cortex, it has a pathway to get there. The commissural tract is what goes through the corpus callosum as it moves from left to right, and then down into the association tracts, which takes it from the brain out to wherever it needs to go. And as I said, we'll see pictures of this. There's long association fibers and there's short ones. If they're long, they're connected more to a lobe of the brain. If they're short, they're more connected to a gyra, which is the folded areas of the brain that we looked at in the last video. Alright, and the last thing to talk about, again, this is that picture that I referenced. So you can kind of see the reddish wavy lines along the surface, or I should say along the exterior of the brain. And again, that's designed to move information, okay, all around the exterior to get it to the right location that handles that. So whether I'm painting with a brush, I'm writing, I'm trying to write a poem, I'm thinking of my to-do list for today, I'm having a particular emotion, all that goes to a particular spot on the cerebrum, and that the association tracts are designed to get it there. Okay, then the commissural tract, as you can see there in yellow, kind of right, not in the middle, but excuse me, that yellow pathway, again allowing the information to pass from side to side. And then once that process is made, and it jumps onto the projection tracts and goes down into the body and wherever it needs to go. Well, that's our video over the gray and white matter. When we come back next time, we're going to talk about the meninges of the brain. We'll see you then.